Alright, so we're here on example 5, and what we want to look at here is the linear equations in real life. So let's read this question. It says a new real estate broker's base salary is $24,970. She earns a 4% commission on total sales. How much must she sell to earn $100,000 in total? Alright, so we can utilize something that we've done before, and that's using the verbal model. And we can write that out just so that we know what step we are on. Alright, so with the verbal model, you're just going to try to verbalize, try to get an understanding of what's happening here. Now look at the last question. It says, how much must she sell to earn $100,000 total? Now the total amount is normally what it equals to after adding something up. So we know we're going to deal with addition here because we're adding the base salary to her commission sales. So the total, we know that we're going to have a total, and it will equal to the base salary added on to something else, and that's our 4% commission, so a percentage commission. So we can write that as percent commission, and a percent commission is always multiplied by something, and that's the sales. And so I just about fit that there. So that's our verbal model. Our total is equal to the base salary plus the percent commission times the amount of sales. Now we just need to simply put our labels in, and we could label it all at one time and just go right to the equation. So our total is 100,000, which is equal to the base salary of 24,970 plus our percent commission. Now we're going to write this percent in decimal form. If you have a calculator that can do it in percent form, you could just do that. But most calculators actually require you to convert it yourself. So 4% as a decimal, remember percent means per hundred, so 4 out of 100 or 4 hundredths, which is the same as 0.04, which is 4 hundredths, times the amount of sales. But we don't know what the sales are, so we can just write X. So that's what we're looking for. How much should she sell? So we're looking for X. So now that we have an equation here, we can solve it. And we just utilize our steps. So we're going to start with the weaker operation. This is multiplication. So we're not going to start there. We're going to start with the weaker operation. And our weaker operation is to subtract the opposite sign, 24,970, and what we do to one side, do to the other. Alright, so these will cancel, and now we just have to subtract that. You could use your calculator. So 100,000 subtract 24,970, and that will be 75,030. So we have 75,000, I think I said 30, 75,030 is going to be equal to 0.04x. And then we're going to divide both sides by 0.04. So once we divide 75,030 by our 0.4, we would get 1,875,750. So that's a good bit of houses, but when you think about today's market, that could be about 3 houses. So if she sold 3 houses for about $600,000, then she could make 100,000. Alright, so that's how we would find that final answer there. And we'll go on to one more problem. Okay, so in example 6, we have equations in geometry. Okay, so this one says you have a 5-inch by 7-inch photo that you want to enlarge. The mat, which you see, kind of that wood mat, and the frame. You want the width of the mat to be 3 inches on all sides. You want the perimeter of the framed photo to be 54 inches. By what percent should you enlarge the photo? Alright, so let's look at this in its detail. First of all, we have a 5-inch by 7-inch photo. So we know that if since it's in a vertical format, that's our base, and then our height will be 7 inches of the photo. So that's the gray part. So the gray part is a 5 by 7. Now remember, the opposite sides of a rectangle are equal. So the base and the top are both 5, and the heights of the photograph are both 7. Now the second part of that question says you want the width of the mat to be 3 inches on all sides. So once this thing is enlarged and put into a new frame, that means the mat part, you want that to be 3 inches wide, right? So from the picture to the frame should have a 3-inch space on each side at the top and the bottom. But not only that, you want it also in the other direction, in the vertical direction. So you want 3 inches on either side there. And so basically you have a 3-inch mat going around the photograph. Right? This next part of that says you want the perimeter of the framed photo to be 54 inches. So the framed photo would be the inside followed by that yellow line. And so all of that should fit in a 54-inch perimeter. So then the question asks is by what percent should you enlarge the photo? Now remember, in the previous question, when you multiply by percentage, it's the same as multiplying by a decimal. Now we don't know what that decimal is, so we can put x there. We're going to multiply the side by x because that would be the enlargement of the percent, and then also the 7 by x. So now we have the dimensions, and we just need to go ahead and come up with a verbal model. Now if we use a model, what we're going to have is the perimeter, which we have is going to be equal to 2 times the length plus 2 times w, which is the width. And we can convert the length and width from base and height. Alright, so the next step we would do is just to label them. We know what our perimeter is, 54. We know the length to be 7x plus 6. And the way we know that, the length or the height is the 7x of the photograph. The first 3, let me see if I can circle that. We have this 3 and this 3 plus the 7x gives us 7x plus 6. Alright, and the same thing happens for our width. For our width we have the 5x plus this 3 plus this 3 gives us 5x plus 6. And that's how we get our length and our width. So now that we have all that, we can go ahead with an algebraic model. We have our perimeter, which is 54, is equal to 2 times the length, which is 7x plus 6, plus 2 times the width, which is 5x plus 6. And now we can go ahead and simplify. Remember to distribute, so we have 2 times 7x, 2 times 6, 2 times 5x, and 2 times 6. Once we do that, it simplifies to 54 equals to 14x plus 12 plus 10x plus 12. That can simplify more by adding our like terms together. And so if we add our like terms, we have 10x plus 14x gives 24x, and 12 plus 12 gives 24. And that's how we get that third line. The next step is, remember to solve by starting with the weaker operation. So subtract 24 to cancel out on that right side. And what you do to one side, do to the other. As stated, the 24's cancel, and 54 subtract 24 is 30, and bring down the 24x. Because 24 and x are being multiplied, you can do the opposite operation with the same number, which is to divide by 24, and what you do to one side, do to the other. Once you do that, the 24's will cancel, and 30 divided by 24 gives x equals to 1.25. Now remember, our x is representing the percentage, and so we just convert that back to a percentage by times it by 100, and you should enlarge the photo by 125%.